But let's add these solutions we are talking today, and if you put these in this matrix form, you see that there are a lot of ITS solutions we can think of which address the vehicle, but addressing the vehicle means you have to focus on the rider too. You see, the rider exclusively can, for example, profit by e-learning from ITS, all intelligent solutions we can think of. Augmented reality, it's very fancy stuff, but somewhere we have to deal with it. Even the road has this part here, and vehicle to infrastructure communication like SimTD, for example, in Germany last year showed that there are interesting solutions too. And at ITS, the e-call issue, at least for cars, it's an issue at the European Commission right now, and it is discussed for bikes too. But the question is, what's the benefit? And I could stop here and say, okay, you see, there are ITS solutions, but the important point is, and that's what I would suggest, is the approach for assessment to come back to the accidents and just checking, are these solutions at least able to address these accidents? I don't know if they can avoid them, but they can at least address them and come up with a ranking to say, okay, there are a limited amount of money, and if we want to come with the most suitable or most promising system, then let's go this way to have a direction. So the approach for assessment, just for your information, we did a case-by-case analysis of 620 accidents for this presentation here, and first of all we defined ITS generic function, because I'm not an ITS engineer and I don't want to come up with a final solution. I just want to think of some interesting solutions. We defined this regarding function, and we had one assumption. If you look at every accident, the assumption was that you focus only on one system, the system that was found most likely to intervene first prior to the accident. Because you can think of different systems which might help in this situation. But to come to a clearer picture, it's for this approach easier. So most of you know these keywords, advanced ABS. We had a statement from Bosch, and the development of technical solutions. It's very interesting, and there are very interesting systems on the market right now. Advanced ABS, dynamic traction control. Bosch, for example, called this MSC, for example. That's an interesting system too. Curve warning and speed limit information, overtake assist, rear end collision warning, junction and crossing assist, left turning assist. That's some keywords and my background is the car safety. And if you talk about ITS in the car sector, you will hear a lot of these names and these functions. And we have to, or we should, apply some of these systems to the needs of the rider and to the needs of the power two-wheeler, to come to a ranking. And if I take back to the accidents and starting with the single vehicle accidents and look at these relevance of these intelligent traffic systems or advanced driver assistance systems, you can call it as you want to, it's intelligent systems. You see, for example, that curve warning with speed limit information might be very helpful. Advanced ABS and dynamic traction control with 60% too, but keep in mind we are talking about just 60 cases, but that's one way to deal with it. And another interesting point, if you start thinking about e-call, you might say, okay, e-call would address all these single accidents. But if you look in detail, case by case, in every single accident, you will see that e-call might be not that beneficial when it looked at the first glance. So we figured out that just 15% of all single vehicle accidents might be addressed by e-call. That's just 3% of all accidents. So there are other systems which might be more beneficial. So let's check the portion where the PTV rider is a causer, and you see you have curve warning again with speed limit information with 21%. That's very interesting system. Rear end collision warning, an interesting solution too, because a lot of these accidents happened in longitudinal traffic. Oncoming traffic warning might be a solution too. And the other portion, that's the part where, not the PTV rider, where the causer, if you look at these accidents, you see that the left turn assist, as probably showed last year, it's a ZimTD project, final project event in Frankfurt from BMW. Might be very interesting for the safety of PTW riders and junction and crossing assist too. And keep in mind, we are talking about not just the PTW rider, the PTW rider. We are talking about the car driver too. I mean, he will get some same systems or even better ones, and it's a question of both parties in an accident to speed up and keep up with technology. So that's the one, or the most important slide, I would say. If I get asked what ITS safety applications might be the most suitable ones for our two-wheeler riders, I would say junction crossing assist and left turning assist are very promising. I try to avoid the word avoiding accidents because I don't know that in detail. We need much more information about the accident, about the pre-crash phase of the accident. But at a first glance, by case-by-case analysis of real accidents, you will come up with similar ranking. So curve warning and speed limit information is very promising. Overtake assist, and you see e-call, for example, I mentioned it, just 3%. That might be not the most important solution if you want to do something good for the motorcyclist. And but keep in mind, the approach of this assessment, as I said, was that we just focused on one system in every situation. So advanced anti-lock braking system or dynamic traction control, or you can name it MTC or whatever, might have a positive effect on every single scenario too. But in this assessment, we had this single approach, otherwise I couldn't come up with a clear picture here. And let's finish and sum up. As I stated on my first sentence, there are promising ITS applications for power two-wheelers which are able to positively influence safety. In order to know to which benefit to further research is needed, and we need a specific impact assessment methodology for power two-wheelers. That's an important issue, and if we want to take safety applications from the car side, always put the rider in the focus, because riding is not driving, and we can't take just an emergency brake assist and put it on a bike. No rider would accept such a system, but we have to keep in mind the rider is a key issue during riding, and we are not driving. And another important point, HMI interface, human machine interface. It's a hard question to deal with. I mean, you don't have a windscreen and you don't have all these screens, and the screens are not that good for distraction. For example, how to say the driver, how to say the rider what he has to do, what is recommended in this situation. It's not an easy task, but we have to, or we should, solve this task in order to have a really helpful safety function at the end. And for now, that would be my statements here. Thank you very much.